Here we're going to share the inputs about nuclear fission and fusion. At the surface, the concept of fission and fusion have been considered for hundreds of years. In the past, it was called alchemy, but the goal here isn't to turn a chunk of lead into gold. Fission and fusion will build up or break down the nucleus of the atom. Fusion is when two or more nuclei combine to create a nucleus of greater mass, all element. Exists because fission from hydrogen atom create larger atoms up through lead. Stars are powered by fusion, creating helium and other elements, and supernova create the heavier element. Fusion requires very high temperature in order to occur for about 40 million degrees Celsius. This has happened in our sun, so high temperature makes sense. Let's look at the reaction of the sun. Sun deuterium is an isotope of hydrogen with 1 neutron, and tritium is the isotope of hydrogen with 2 neutrons. When they collide under high temperature condition, they form a helium atom with 2 protons and 2 neutrons. They release neutron written with the lower caste and for the symbol, and they release huge amount of energy. Now, it would be amazing if we could harden this massive release of energy to fit our need for electric energy. But we require temperatures that are very high and very difficult to attain, and reaction itself is nearly impossible to control. To get the high temperature to start the reaction, that we need something like a nuclear bomb, and once that are going, good luck trying to control it. Fission is in a small part of opposite of fusion. It's the splitting of the nucleus into smaller fragments by the release of neutrons and lots of energy. But nuclear fission will only happen when neutron hit one of two fissionable isotopes, uranium-235 or plutonium-239. First, neutron hit uranium, make it unstable, break into two smaller parts and release 3 neutrons. If neutron hits other uranium atom, it starts chain reaction. What is chain reaction? Chain reaction is the fission release neutron which hit other fissionable atoms, producing more neutrons. We can react with even more fissionable atoms, producing more neutrons.
Next, we can harness the energy released from fission much more easily than harnessing fusion energy. Nuclear reactors are the heart and soul of nuclear power plants. We use control fission in fuel rods that are cooled by coolant fluid, usually water. The heat from the core is used to generate steam, which will drive a turbine that creates electricity and a generator. The large towers that you may be used to seeing are actually just for cooling down and condensing the water, so that it can be reused in the system. There's no radioactive material in those cooling towers, just steam. The fuel rod is one of the example material made of a metal which contains uranium-235 or plutonium-239. Now perhaps most notoriously fission and fusion can be used in nuclear weapons. The fusion bomb, also known as the atom bomb, includes weapons whose explosive output is exclusively from fission reaction. Thermonuclear bombs are weapons that use fission to trigger fusion reaction with tritium, deuterium or lithium deuteride. In order to get the fusion reaction started, a fission reaction must occur first to create the high temperature that are needed. The fusion reaction doesn't create nuclear fallout, but the fusion reaction does. Thermonuclear bombs are the most powerful and potentially destructive nuclear weapons. Okay, that's all. Thank you.